recording for this one. Okay, so since we're going to learn today is called arrow diagram, which another way we call is activity on arrow. Okay, so that is the activity. I to J here, it's on the arrow. So that is the arrow. So that is what we call it, activity on the arrow. So so that is an example. The percentile diagram or the activity on node diagram we had before is like this. So this is activity A. And it's starting like that way. But for here, you only using one node to represent the activity. But in the activity on the diagram, we need to use two nodes. So one is here and one other is here. So we have the I nodes and the J nodes, right? So the I nodes is the left one and the J nodes is the right one, because we're all assuming that is started from the left side and the pump out to the end by the left side, right? So I take the wrong way. So this is the end. And in the right side. Sorry for this. So another way we have see some rollers of the rows over here. How to using those nodes, because we cannot put in the nodes as an I and a J here. So we have to put in the number here. So we'll see how it looks like. Okay, so that's kind of like the things we're going to do by the next 2 weeks within it. Okay, so first of all, let's see. The arrow diagram is an arrow as activity. Task that consuming time. The length of the arrow does not have any meanings. So you can do something like this long, or you can do some like this short. It doesn't matter. So this length is no means, okay? So just the mean there is a link the node I and the node J, okay? Let's continue. So the nodes as events. So as we refer to the events, it means they're not consuming any time. It's just a time point, right? A point in time or an instance. So each activity is I nodes, which refer to this starting one in the left, should be smaller than its J nodes, which is any one in the right. So you can leave in gaps, allow for virtual network additions. So what that means you have a nodes here. So normally we do is 0, 5, 10, 15. We're given as a 5 as a gap. So you do this one, 0, 5, that means the activity, if we see this is A, activity A is using the nodes 0 to 5 to present it, right? And then you have 10 here, then activity B is 5 to 10. So we may add something to that. Then we have C here, and then we can make this as 4. So, and you have D here. C is 0 to 4, and D is 4 to 5. So if you have gap over here, that means you can still adding some activities in your network model, right? So make each activity I and the J node combination is unique. So you can see my example here, very simple one. A is 0 to 5, B is 5 to 10, C is 0 to 4, and D is 5 to 4 to 5, which is all different, right? And also you need to make sure all those starting one in the left, I mean the I is always less than the J in the right. So 0 is less than 4, 4 is less than 5, 0 is less than 5, and the 5 here is less than 10, right? So those are the 3 requirements for each of the nodes. You are using the numbers 0, 5, 10, 15, or you can use 0, 10, 20, 30 to represent them. That doesn't, it all works, okay? So I prefer to using the gap at 0, 5, 10, and 15. So we will see more cases later. This is just a quick review what is the arrow diagram looks like, right? So so to break it down, here is a check-in code as well. You can use this one to check in. So activity relations means we have learned a couple of activity relations in the percent diagram before. We have finish to finish, right? We have finish to start, start to finish, and the start to start. And the finish start is the very simple one. So for here, we see about the activity relations is not referred to this. It's referred to the activities. Either is one-to-one relation, like the example showing here, or it is referred to one-to-more relations, like in the next page showing, okay? Let's take a look at this. You have several basic types of the relations are found in the arrow diagrams. So this slide, you are showing the activity B and the percentages over here. Again, this table coming out again. Remember, we will have, this can also be called as intermediately presenting activities, IPA, right? And if you see this table, you probably the next step you are doing is adding a column here. We call that is sequence number, right? You may do the calculations. So when we're doing the practice, we will show how to do the calculation here, which is similar as the activity on the node that percent diagram, but we will do more practice over here. Okay, you have the activity J over here. The activity G over here is after the percent is B. So that means if I do this as a percent diagram or activity on the node, you will see this will be B, and then we have next activity is G here, right? So that is the percent diagram AON. So we use this one for the CPM calculation for a lot. So, but if we convert this one into the arrow diagram, you will need at least 1, 2, 3 nodes because we have 2 activities here. So here is activity B, and here is activity G here, right? And you will see the activity B, that is I nodes, and this is J nodes, and to the activity G here, that is I nodes, and this is G nodes, right? So refer to this one. So you have the activity I to J, right? So then you have the B here is 1 to 5, and you have G here is 5 to 7. So you can check 1 is less than 5, and 5 is less than 7. And 1 to 5 and 5 to 7 is all unique, it's all different. So this is one-on-one relation between 2 activities. Any question? If no question, we are moving forward. If you have any question, please ask. Josh?
No questions.
Okay, sounds good. So then we move into the next page. So the next page is continue with the basic type of relations found in the arrow diagram, but this is mailing on one relation, so among several activities. So you will see this again. So what we do is we were using the AON or percent diagram to show it first, right? You have B and the F, G, and H is all following the B, right? So you have F, G, and H. So this is how using the percentage diagram to present it. And in the same way, we can use the arrow diagram to present. So first you have the B here. And then second, you have the F and the G, and then you have the H. So that's kind of the same thing we're doing. So we need to check. So you have the B here is 1 to 5, F to here is 5 to 6, and the G here is 5 to 7, and the H here is 5 to 8. So those are the difference, right? So none of them are the same thing, and all of them are following the rule here, which is the I is less than J, right? So so that kind of similar to this one. So in the quiz or the assignments, you can try to getting activity on node diagram faster, and then you compare your results to make sure you're getting the done correctly with your arrow active on arrows diagram correctly. Okay, so that is a strategies you can do and to check, make sure you getting it what we want, right? Okay, any question for this mating on one relation? So basically it's just the extended, but the share with these nodes. And also you can see the number here is 1 to 5, which is okay, and then for here is 5 to 6, 7, and 8. I think that will be another one will be showing here is a 10. So maybe all those is coming to it, and or may not, right? So, but anyway, if you have in the nodes is not the last number over here, those should be connect to something to represent a new activities. Okay. Madison, do you have a question?
Wait, Dr. Johan. So basically with this is basically kind of like how you drew it, where we had the nodes and we just connected to the sequencing
Yeah,
numbers.
we will show you how to do this in a practice example. And for this one is more likely to show you they have different relations, and those relations you can use in your diagram. Yeah, and basically what we will do is doing the sequence number calculation first, and then putting those things in the column, because you still can do is you have the different column, right? You can put in A here, B here, and C here, and then you will do those, right? And then make a connection. Okay, we will do this. No worry about that one. So first we need to understand the relations. Okay.
Okay, I got you.
All right, so we move into the next one. So the next one is a additional relation here is one on mating relation. So which is reverse to mating on one relation. So you have this percent diagram percentage over here, and then we can try to make it, you have A here, B here, C here, and all those is come to the G here, okay? Something like this. And you convert this one into arrow diagram will be like that. So starting from 0, and the activity A is going to the 5, and you are using 5 to 7 to represent the activity G here, and then you're adding B, because you're already using the zero, so you can only use one. You're already using the two, then you're already using the one, then you are using two here, right? So that is the one on mailing relations. Okay, so we can write it down. So the A is 0, 5, B is 1, 5, C is 2, 5, and the G is 5 to 7, which are all different. Okay, so I think next one will be the mailing on mailing relations, because we already have one on mailing on one, and definitely we will have the mailing on mailing relation. So mailing on mailing relation here. So first we're using the table to getting a percent diagram, right? A, B, C, and F, G, and H. So for that one, you will see a little bit of tricky here. Okay, we'll see. A is point to F, B is point to F, and C is point to F, right? And then you will see A is point to G, B is point to G, and C is point to G. And then you will see A is point to H, B is point to H, and C is point to H. So that looks massive, right? So, but you have all the relation correctly present over here. But if you're using activity on the arrow and with many on many relation, so you can do is A, this is your activity A, this is your activity A, 0 to 5, activity B, 1 to 5, and activity C, 2 to 5. So they all have an intersection over here, and using that as a point to starting with the following activities F, G, and H. So you will have A is 0 to 5, B is 1 to 5, C is 2 to 5, and the F is 5 to 6, G is 5 to 7, and H is 5 to 8. So all those are different. So that is kind of going to give some advantages. Activity on arrow or arrow diagram is better than this presenting that diagram, right? Any question for here?
I think we're good on that one, Dr. Yuhan.
Thank you. So then that's the challenging thing coming out, which is the dummy activity. So for all those relations we presented before is all solid line, right? Straight and the solid line, or maybe they have some curve over here, but it's a connected line. But when we were using a connected arrow or connected link over here to present activities. Each of those is an activity, right? So we have 6 arrows over here, then we have the 6 activity. So that is because for those activities, it's really consuming the time. It's construction activities. You need to spend times, days, either 1 or 2 or 4, depends on the quantity and also the productive rate, right? So, but they have something new coming here is called the dammings. The damming activities, you can treat it as an activity, but it's no durations. So if that is a damming activity and it's no durations, then we will using the dash arrows here to represent it. Okay, so the dash arrows over here is represent the damming activity, and the damming activity does not cost any time. There's no duration for damming activity, and this is damming activity is not shown on this table. So no damming activities in this table, okay? So that damming activity is you going to create it to refer to the logistic, refer to the sense happen over here. For example, you have two activity R and S over here. You want to present it. You cannot using the same. You cannot using the same two nodes, because in this case you have R is 10 and 15, and S is 10 and 15, which makes the two are not different. They are the same. So we cannot accept that happen. So in that case, we need to adding a damming here. So this damming is 10 to 11. And you have the R here is 11 to 15, and S over here is 10 to 15. So that makes you three activity here, even how the damming including have the different starting and ending I and J point, right? So so to getting a damming, you will make sure damming is not consume any time or any resource. So damming still needed to follow the neighboring rules. You will see this damming is 10 to 11. 10 is different to 11. 10 is less than 11. And also you have all those three activities over here, including the damming, show the different I and J combinations, right? So this is what we are talking about it. Okay?
Wait, so question, Dr. Yuhan, what you're saying is that the dummy activity, you still give it a node or you don't give it a
Yes.
node?
The
Okay.
damming activity, you should have a node. You have the node here and this one. So this is your damming, starting from, this is your damming node I, and this is your damming node J, okay? You still need to give them node. Okay, so that's the case here. Let's take a look at the activity here, what we can do with it. So you have A is point to R, and also is point to S. And then you have R and S is point to the T, right? So that is your activities. That is your diagram looks like for this table. So how can we do this one and getting the results that's an arrow diagram instead of this presenting diagram, right? So let's take a look how to do it. So we can't actually know this is a simple one, only have 3 columns over here. You can go ahead to do the calculations for the sequence number, right? Sequence number calculations, you get a 0, 1, 1, and 2 here, right? This is 1 plus 0 and 1 plus 1, right? So what we do is we can do like in this way. We still have the sequence number. We get a 0, 1, and 2. So we look at this. We look at this is sequence number 0. So we're putting A here. And we look at the R and the S is in the second column here. And then we look at the T is in the second column here. Sorry, that is the third column here, but we not named as 2, right? So again, we were using this A as an arrow diagram. So basically you were starting with a starting nodes. I is here and this one is here. So what do we do? What we do is we need to creating a R here, right? So we can easily do it like this. So we name this as 0, 5, and 10. We can do the name later, but if it's easy, we can do it, right? And then we will have the S is after A, so we can come out like this. So how we end it? So if we not care about S, we finish the T here first, and we have 15. So the question here is, S is also the starting one. S is also the presenting one to the T. So can we link like this? So now I'm done. Can we have the join like this? The arrow network join like this? So the answer is we cannot. Why? So let's check. So the neighboring is fine. We have 0, 5, 0. So we have A is 0, 5. And R is 5, 10. And S is 5, 10. And the T is 10 to 15. So that is because those two are the same. That should be the same activities. So we cannot accept that. So this one, I using the red color to highlight the one will be changing. And how to do the change? That is using the dummy here. So you can do is create a dummy here and make sure you have a notes here, and then this is your dummy. And that is your S. Now we're given here is 6. So we have a dummy. 1 here is 5 to 6. And then in that case, we will change the S here is to 6 to 10. So then we check again, none of the any combination of the I and the J are the same. Okay, so question here. So make sure you have this. Question here. If no question here, I have a question. My question is, are you still listening to me?
Yes,
Yeah, really
Dr.
cool,
Yuhan.
Dr.
Okay, good. So yes, so that is why we need to have a dummy here, and the same as here. So the number is maybe different to mine is 5 and 6. This is 10 to 11, but the goal is the same way. So this can also be changed for this one as well. So the dummy can add in the press from A to T through the S, or adding in the parts from A to R to T, so which are the same way. So basically you can change this one to S and change this one to R, which is that is, okay? So that is a dummy. Dummy is a very important thing. We may need to go back to see this again if we are adding questions later, okay? So this is another case for dummy. So the most dummy are required to maintain the property logic. That is, I mentioned before, the logic, all right? Because when you have multiple activities, that will really needed. So let's first take a look at these 4 activities over here. So you have A and the B, which is 0 here. So you are the 2 starting points. And you have the C here is next to A and B, but you have D here is only next to B. So that is the percentage diagram looks like for that case. And how the dummy or how the error diagram looks like. So can we use that one? If we're using that one, we can check. So you have A is 10 to 20, and the B is 50 to 20, and the C is 20 to 25, and the D is 20 to 30. So it looks like those are the different, right? Those are the different. And then if the nodes numbering you're checking is correct, and then we still need to check about the which one? You show the property logic. Do we still have the property logic? Let's check. So you have activity A here and activity B here. So A, B here, and if we share these nodes here, that make A is percenters to C, A is percenters to D. So that's incorrect because D is only after B, right? So that means how to access that to you. So that means A over here is linked to D. Does that make sense? Because you are still in the same path or chain over here. The A is connected through the 20 and going to D. That means A changed to be A is a predecessors of D. That is incorrect. That is incorrect, right? The table does not give you that information. That is only the B is the percentage to D, and the C, A is percentage to C, so that is okay, and that is wrong, okay? So how to fix it? To fix it, you will maintain a property logic of various constraint activities. You need to use a dummy. So let's see how they fix it. Okay. So let's check the following one. That is correct answer. You have A is going to C, right? And the B is going to D. And the B through this timing is going to C. But A cannot go to D because there is no arrow, right? There is no arrow going that way. Here is only an arrow go out from the 20 to the 25. That is C. Okay, so this arrow to make sure we cannot, this is a dummy. And the 16 to 20 over here is going to represent the relations correctly without causing adding relations. So and another question, another thing I want to notify you is, so some of you may starting to using the straight line to do it. The straight and a connected arrow here. So make sure when you have a straight and a connected one, this must be a activity in the table. This must be an activity in this table, okay? If you cannot given a name for this, this is different to them, which is 5 is different to A, B, C, D. That means it's not existing. So if it is not existing, you cannot using a continuous straight link to do it. You need to think about the dummy. And also make sure if you're adding the dummy, is going to maintain the property logic. Because when you're adding the dummy, you will break a logic, or you may create a new logic, which may be wrong. So you need to make sure it's correct, it's necessary. If it's not necessary, you don't need to have it. So make it simple, make it clear, make everything is necessary. That is our goal, okay? Any question for this one?
No questions.
Thank you, Josh. So then we see the next one. The next one still is a dummy. So let's take 3 minutes over here. Let's draw a presenting diagram or activities on the node here for this one. Okay. I give you 3 minutes here as a short break here and try to draw the diagram for this one. So you can using the sequence number to help you to do it. So please let me know if my sequence number is correct or wrong. All right, so let's see how the result looks like. You can check with your own as well. So so we have A is pumped to D only. A is to D, and we have E is required from A as well. D is required from B, and F is required from B. C to F. So that is the presenters diagram. I'll see the activity on the activities on the node. You all get a similar result with me or different?
I got something simple.
Thank you for confirming it. Yes. So okay. So we got that one. So can we try to do the activities on the arrows? Activities on the arrows. Because you are using this as a refer information to try to do activity on the arrows. And we can do the same thing. We put A here, B here, C here, D and E and F. So I'll give you 5 minutes to try this one, see if you can figure out how to do it. So some of the information below here is correct. Some of the wrong. Don't trust it. Okay, you just hide those. Try to do your own. Okay, I'm going to hide those. See, can you do this one in 5 minutes? So don't trust that one. Just do it. All right. So so for that one, it looks likely we have A to D, A to E, B to E, B to F, and C to F. 1, 2, 3, 4, 5. 5 relations over here. So it will be safe to do it because you can always do the first one, and you can either assign one of that, one here or there here. It doesn't matter, okay? So then you will be ending this one because you have the first one, the smallest one, then you are ending here by another one. So that is activity A. So for the relation A to D, so basically is D is after A, right? So that means D will be starting from this 5. Oh, I did not mention this. This I note we call is a starting note. And this J notes we call is ending notes, right? And if the relation is D is after A, that means that is I for D. Does that make sense? So this note can be a starting note for the next one, can be the ending notes for the previous one. Okay, so that means you have here is 10 as D. So there's no issue for this one. It's very straightforward. So let's look at the next one. So you will see they has a relation between A and E, right? So if there is nothing else over here, I can very safely to do this. So if there is nothing relation over here, right? And I tried this one as 15. Okay, or even I don't give a number for this one yet. So if there's no other B, C, and F, this is correct. A to D here. Okay, A to D we got it, and A to E we got it. Do you agree with me?
Yes, sir.
Okay, good, good. So
Yes.
so now we finish A, and we're looking for B. Okay, so we're looking for B. So the B is going to which one? B is going to E and F, right? So if we want to make B going to E, then we probably need to do something like this. So that is how to make B go to E. If we're doing like this, that make a trouble over here is this B is going to D as well. Do you agree with me?
Yes.
So is that correct or that is wrong?
I just
Wrong.
transferred from
Wrong.
B to E.
Yeah, that is wrong because if you type this, that makes your B is go to D as well, right? So because they share the same 1, 5. So B can go to D and B can go to E. So we need to stop this happen. So how to stop that happen? So if we want to make the relation properly, we need to use the dummy here. Okay, so that is why we need to use a dummy, and we don't want to creating the wrong relations over here. We want to maintain it, right? So so in this case, I will going to creating a node here for B first. And if I want to get in the relation from A to E, so if I don't want to do this first. I just want to get in a relation B to E. So that is correct, right? And if we want to add in the relation from A to E, so we can add in a dummy here. So this is your dummy. Is that correct? If we're only looking A, D, and B,
Yeah.
we're not looking CF. So it's correct, right?
Yes.
Yes.
Okay, yes. So the B, from right now, the B is only able to go through to E. And the B is not able to go to D anymore. But A is able to go through D, and A is able to coming down through the dummy go to E as well, right? So that is the dummy. Dummy help us to maintain the relations and without creating any issues over here. Okay, I'm not going to name it. The name is the easy thing. So let's see if how we can finish our relation, go to the
Quick
B
question.
and F. Go ahead. Yeah.
Do you have to put the dummy from the middle from the 5 to that, or can you go from the 1 to the middle of the orange line?
Good question. So if you dummy come from here, right? So is that what you refer to?
Yeah, that's how I drew mine.
So if you refer this, remember this one here is the starting point of the A. And this is not the ending point of the A. The ending point of the A is 5. If you put in dummy starting from the 1, that means you're starting the A in the same time you're starting the E. It's not means you finish A and then you start with E. Does that make sense?
Yeah, it does. Thank you.
Okay, so we cannot do this, right? So make sure the relation we're showing over here is all finish to start. So we're not going to mess up you with any start to start, start to finish, or finish to, sorry, start to start, finish to start, finish to finish. We only have the finish to start relation here, okay? So then we can only using the 5 here instead of this one. Okay, let's look at the next one. The next one, we have the relation between the B and F. So I don't know how to connect F, but I know F should have an ending nodes, right? And if we're putting a starting nodes over here, I will see if we can do this, right? So can we do this? So we don't have this starting node, we just link from here. Can we do this? Because in this one, we have B throwing these nodes and knowing nodes here and go to the F. And the B, putting a color here to easy to refer to it, right? Okay, we're throwing this green nodes, we have B to E relation, we have B to F relation. Does that make sense? So question me, please, question me, or question yourself, is that correct?
Why would you do that? Do it like that?
You would like to do like this. If you do like this, you have adding a relation from A to F. How that happen? Let's see. Okay, through this green one, you have A through this dummy and coming down. Does that make sense? So if we do like this, we have created a relation. It means A should have some connection with F. But exactly we don't have this, right? So Grace, do you have a question?
No.
Okay, so thank you. So we not have that one. So that means the same I did with this blue line for the F is incorrect. So we're going to put in a note here and a question here as well. Okay, so, but we still want to have the relation between B and F. We cannot using this green dots over here. That means we need to creating a new dummy here. Is that correct? Do we need a second dummy here?
Yeah.
Okay, good. Thank Josh for confirming it. So if we need a second dummy here, that means the dummy will be pointed to this one and where? From where? From somewhere it's the relation is going to confirm with the B, right? So probably we need to broken this B here and put a dummy here. So make it a realistic, we're moving a little bit. So we do right here, right? So this is a dummy. So this is a dummy. We're creating that one, and we see this is a dummy. Second, this is first, right? And we make sure a B is goes through in this dummy. B is goes through in this dummy and connect with F. And the B is connect with E through in something. We may need to fix it because can we have this straight line over here? Can we? Can we have this continue the straight arrows over here?
Yes, because it still needs to go to E.
Any other sorts here, different sorts here?
Why wouldn't you put the dummy in the same spot as the first one?
So the answer is we cannot have a straight line over here. We cannot have a continued link over here. It's because if we put any continued link over here, that means that is activity. That activity should show in the table. But we only have A to F, 6 activity here. We don't have that one. So we cannot put a strict continued line over here. We can only put a dummy here. So this is a dummy. So this is what be your dummy 3. Does that make sense? So you need a dummy here because you need to maintain the relation between B and E. Am I clear? Is that clear to you?
Yes.
Okay,
Yeah.
thank you. All right, so then we have the last one. So the last one it is C. And this C will be pointed to F and without any other relations. So so now we can starting to name them. So you have 1 here, 5 and 10 here. So since I'm in the same column, so you can call this is 2 and call this is 3. And you call this is 4, 6, 7, 8, 9. So the naming them is easy, and you can check. A is, so A is 1 to 5, B is 2 to 4, C is 3 to 7, which is all the I is less than I, right? And the D is 5 to 10, E is 6 to 8, and F is 7 to 9. It's all less than I is less than F, and all those are not same thing, right? And then you will see the diamond 1 is 5 to 6, diamond 2 is 4 to 6, and diamond 3 is, actually this is 3, and this 2 is 4 to 7. So all those are the unicorn. Now, no one sharing the same thing. And then we checking the relations. Whether we're creating any new, no, we only have 3 diamonds over here, no other straight line, and without any labels, right? And we're checking A is going to D, correct? A is going to E, correct? And A cannot go anymore. B is going to E, B is going to F, and B cannot go anymore. And then C is going to F. All right, so you don't need to hide this. You can just use your pen to go through it and make sure you have those, right? So for example, you can do this. Then it's displayed, right? Question?
Yeah, can you explain the dummy 2 and dummy 3 again?
So the diamond 2 here is 4 to 7, and the diamond 6 here, diamond 3 here is 4 to 6, right? So okay, so this diamond 3 adding here is because we need to maintain the relation between B and E. But we cannot put a straight line over here. We can only put a diamond here. We cannot put a continuous line here. If we put a continuous line, means we need to have an activity here, right? And for the diamond 2 we put in here is because we need to maintain the relation between B and F. B and F. The reason we need a diamond is because we tried to connect 6 and 7 directly, but if we connect 6 and 7 directly, that cause us has a relation between A and F. So we cannot do this. So we needed to broken over here. So we decided to go this way. Does that make sense?
Yeah, it does. Thank you.
Okay, great. So any more question over this one?
No, Dr. Yuan.
Good, sounds good. So what's the time now? It's 2:07. So let's see if we can give him one more slide over here. So you can check the result over here. So that means the second one, the B is correct, right? So how we getting the B, we already explained over here. So I'll put the video on the YouTube, and you guys can check it later if you want to go through it. All right, so here is another example here. Showing the 2 diamonds over here, and then 2 diamonds over here. So each of the diamond is required to maintain the property logic in the diamond. So the question over here, or the purpose of this slide here, is asking you to see if I can reduce any of those 4 diamonds. We can try, think about it. If I reduce this diamond, so if I reduce this diamond 3 here, that means this 15 is no longer existing here. right? This 15 is no longer here, and then that means we are going to connect this one directly. So this will be no longer 15, and this will be your dressing the shoulder. Can we do this? Can we remove the dummy 3 and connect the 45 to 55 directly and make that is your dressing the shoulders? Josh?
I'm sorry, can you repeat that?
So can we remove those dummy 3 and directly connect 45 to 55? So like here, directly connect those two.
No.
No, why?
It's
So
the
why?
same.
The same combination of the node I and the J, right? Because you have those cutting and those dressing sharing the same 45 and 55. So this repeated twice. So the answer is no. Thank you, Josh. So let's take a look at another one. Can we remove this one? Can we remove this diamond 4 and directly connect this one? So connect 55 to 16 without a dummy. Can we do this?
Yes,
Why?
Yes.
because nothing else connects to 60, but 55.
So the answer is we cannot remove this dummy. It is because this one is no activity. It's only a dummy. It's not see here is move out, right? If we have here is move out, yes, you can, but here is not a move out. So it's dummy. It's only adding here to maintain the logic over here. So we cannot do this. Does that make sense? This one you need to have
Yes.
it because it's activity over here. If we have a move out activity here, then the answer is yes. But if no, we cannot remove it. Okay, so we needed to maintain this timing as well. So again, we're coming down to see the dummy 1 and the dummy 2. So think about it. Can we move the dummy 1 and the dummy 2? The first one is, can we move in the dummy 1? If we're moving the dummy 1, so this one is not evating, and then we will combine this together. So this will be a new node here. Right, and this nodes maybe 30, maybe 40. So let's try make it as simple as 30. Okay, so you have the 10 to 30 is set up the batch plate, and you have the 10 to 30 is excavates. So we have the two activities share the same 10 to 30. So that is incorrect. So same as over here, right? So we need to keep this dummy. So the dummy 1 is safe. We needed to have it. Same reason as dummy 3. So the next question is, can we remove this dummy 2?
No, because it would put it would make a sequence from 10 to 30 to 35.
Yes, that is because we want to have this set up the batch plate as the preceding or the before activity to pour the payment. Okay, so that is using to maintain the relation here is set up to the pour the concrete. If we don't have that one, that means the payment can be due without this setup. Okay, so any question so far for today?
No, sir.
No
Okay,
question.
sounds good. Thank you. No question. That's great. And then we will ending here by today, and I will upload the